What if I told you the Big Bang never happened? Not because some religious zealot wants it that way, but because the very question, what happened before, is like asking what's north of the North Pole. You see, we've been trained to think time is this river flowing one direction, past, present, future. But what if time itself is the illusion? What if the universe didn't start at all, but we just can't think outside the box our brains built for us? Stick with me, because once you see what I'm about to show you, you'll never look at a clock, a birthday, or even your own mortality the same way again. Now I know what you're thinking. You're thinking, Feynman, you've lost it. I've seen the documentaries. I've read the articles. The Big Bang is settled science. We know the universe is 13.8 billion years old. We have the measurements. We have the cosmic microwave background. We have Edwin Hubble's observations. This is done. This is proven. And you know what? You're both right and catastrophically wrong at the same time. And that's exactly where this gets interesting. Here's what this video is going to do for you that no one else is willing to say out loud. It's going to give you permission to stop pretending you understand something you don't. And more importantly, it's going to show you why not understanding is actually the more intellectually honest position, and ultimately the more liberating one. You've been lied to. Not maliciously, but culturally. You've been told that science has proven the universe began 13.8 billion years ago in a cosmic explosion. You've seen the graphs, the cosmic microwave background radiation maps, the confident pronouncements from scientists in lab coats standing in front of blackboards covered with equations, and somewhere deep inside, you nodded along while a quiet voice whispered, "But what was before that?" And when you asked, maybe to a teacher, maybe to a professor, maybe just to yourself late at night, you got hand-waved away with, "Time didn't exist yet," or, "That question is meaningless." And it felt like a cop-out, didn't it? Because it is a cop-out. Here's the reframe I want you to hold on to. The Big Bang is not a creation event. It's a description of what happens when we run our best equations backward until they break. It's the horizon of our current understanding, not the edge of reality. Confusing the two is like ancient sailors thinking the ocean ended where their maps did. They'd draw their beautiful charts, accurate and detailed for the waters they'd sailed, and then at the edge they'd write, "Here be dragons." Not because there were actually dragons out there, but because that's where their knowledge stopped. That's where the map ended. We've done the exact same thing with the Big Bang. We've found the edge of our map and declared it the edge of the world. What you're going to get from this video is clarity about what we actually know versus what we've mythologized. You'll learn to think like a physicist, to hold uncertainty without collapsing into either dogma or nihilism. And you'll walk away with a completely different relationship to existence itself. Not as a thing that started, but as a thing that simply is, in ways our monkey brains are only beginning to glimpse. This isn't about answers, it's about upgrading your questions, it's about learning to be comfortable in the vast, beautiful, terrifying space of not knowing. So let me take you on a journey, not through space or time, but through the architecture of how we think about space and time. Because that's where the real revolution happens, not in the data, not in the telescopes, but in the way we frame the questions we're asking. Imagine you're an ant. I want you to really picture this. You're an ant, and you live your entire life on the surface of a balloon that's being inflated. You don't know it's a balloon, of course. To you, this surface is the entire universe. It's all that exists. You can walk north, south, east, west across this surface, and it seems infinite to your tiny ant perspective. But here's the thing that's happening without your knowledge. The balloon is being slowly, steadily inflated. And as it inflates, you notice something absolutely remarkable. You notice that all the other ants, every single one, is moving away from you. No matter which direction you look, everyone's receding. The ants to your north are getting farther away. The ants to your south are getting farther away. Every ant, in every direction, moving away from you at the center. Now, you're a smart ant, a physicist ant. You went to ant university, you studied ant mathematics, and you're good at this. So you start thinking. You think, if everyone's moving away from me and I run this process backward in time, that means we all used to be closer together. In fact, if I extrapolate backward far enough, there must have been a moment when we were all touching. There must have been a beginning, a moment zero, when all the ants were in the same spot. So you start calculating. You measure the speeds at which the other ants are receding. You work backward. And you find it. You calculate that 13.8 billion ant seconds ago, you were all at a single point. The great squish, the primordial touching of all ants. You announce your discovery, you publish papers, you give lectures, you win the Ant Nobel Prize, you're famous, you're celebrated, you've discovered the origin of the universe. But here's what you missed, and this is crucial. You live on a surface. The balloon has no center on the surface itself. If you're an ant confined to the two-dimensional surface of the balloon, there's no special point that's the center from your perspective. Every ant can legitimately claim to be at the center because everyone else is moving away from them equally. The expansion is happening everywhere at once. The beginning, you calculated, that primordial point where all ants were touching. It isn't a place on the balloon. It's when the balloon was deflated down to nothing. But here's the question that should haunt you. Does that mean the balloon itself didn't exist? Or does it just mean the balloon was in a different state? Maybe the balloon was always there, just scrunched up, compressed, waiting to be inflated. Maybe the balloon goes through cycles, inflating, deflating, inflating again, like a cosmic lung breathing in and out. Maybe there are infinite other balloons you can't see, can't detect, because you're trapped on the surface of your own. The point is this, and I need you to really hear this. Your equations describe the surface's expansion perfectly, beautifully, with stunning accuracy. But they can't tell you what the balloon is made of. They can't tell you whether it had a creator who tied it off and started blowing. They can't tell you what's outside the balloon in the larger room. You've described motion brilliantly, but you've mistaken that description for ultimate truth. You've confused the map for the territory. That's us. We're ants on a surface. We're trapped in our 3 spatial dimensions plus time, extrapolating backward to a singularity and calling it the beginning. We're calling it the Big Bang and declaring the case closed. But we might just be at the limit of what our dimensional perspective can see. We might be looking at the edge of our map and mistaking it for the edge of reality. And you know what's beautiful about this? It means the mystery is deeper than we thought. It means reality is more interesting, more strange, more provocative than everything started 13.8 billion years ago and will end in heat death. That story is too small, too tidy, too convenient for creatures who desperately want beginnings and endings because that's how we understand our own lives. But wait, if the Big Bang isn't the beginning, then what is it? What are we even talking about when we say Big Bang? Hold that question. Let me show you something even stranger first. Let me tell you about a student I once had. I had this student, brilliant kid, genuinely one of the sharpest minds I'd encountered in decades of teaching. Sharp like a knife. Sharp like broken glass. The kind of smart that sometimes cuts yourself on. He came to my office one afternoon, and I could see he was absolutely tortured. Hadn't slept. Had that wild look in his eyes that you get when you've been thinking about something so hard that you've forgotten to eat, forgotten to blink, forgotten that other people exist. I knew that look. I'd worn it myself many times. He sat down and he said, "Professor Feynman, I've been thinking about time, specifically about how time could begin, and I'm stuck. I'm completely stuck, and it's driving me insane." I leaned back in my chair and said, "Okay, tell me about it." And he starts talking, fast, like if he slows down he'll lose the thread. He says, if time started at the Big Bang, what does start even mean? To start implies a before state and an after state. Something wasn't happening, and then it was happening. But if there's no time before the Big Bang, the word start becomes meaningless. We're using language that requires time to describe the origin of time. We're trapped in circular logic. It's like trying to use a ruler to measure the first inch of the ruler itself. I looked at him for a long moment, and I said, "You're absolutely right. You've discovered something that most physicists spend their whole careers very carefully avoiding thinking about too hard." He looked relieved for about half a second, and then the relief turned to terror. "So, what do we do? If the language doesn't work, if the concepts don't work, what do we do?" And I told him something I want you to hear too. I said, "We get comfortable with paradox. We accept that our language, the words we use, the grammar we think in, evolved to describe medium-sized objects moving at medium speeds through medium amounts of time. Rocks and trees and people and horses. That's what our brains are built for. That's what language is optimized for. When we try to apply that language to the origin of the universe, to the nature of time itself, it breaks. Not because we're stupid, not because we're doing it wrong, but because we're asking our tools to do something they weren't built for. It's like trying to use a ruler to measure justice or a thermometer to measure love. The tool isn't broken. The tool is just the wrong tool for the job." The student sat there quietly, processing. Then he asked the question I'd been waiting for. He said, "But doesn't that mean we can't really know? Doesn't that mean this whole enterprise is kind of futile?" And I said, "Exactly. We can describe, we can measure, we can predict with astonishing accuracy. But knowing in the deep, ultimate, capital K knowing sense, that might not be available to creatures with our cognitive architecture. We might be like dogs trying to understand calculus. Not because dogs are dumb, dogs are great, but because their brains aren't wired for abstract mathematical reasoning. Similarly, our brains might not be wired to comprehend the true nature of time and existence." I leaned forward and I said, "And you know what? I find that deeply comforting. I find it beautiful, because it means the universe is more interesting than our brains. It means reality is under no obligation to make sense to us. It means there's genuine mystery baked into the structure of things, and no amount of clever equation writing will dissolve it completely. That doesn't make science useless. It makes science humble. It makes science honest." He left my office still troubled, but differently troubled. Before, he was troubled by the paradox itself. Now he was troubled by the infinity of what might lie beyond the paradox. That's progress. That's the beginning of real thinking. That's the moment when you stop being a student reciting answers and become a scientist grappling with reality. So if our language breaks down, if our concepts fail us, how do we think about this? What tools do we actually have? Let me show you what the math says, and more importantly, what it doesn't say. All right, story time is over. Let's get into the deep water. I'm going to give you 3 core truths that will completely reframe how you think about existence, time, and what we call the beginning. These aren't easy truths. These aren't comfortable truths, but they're honest truths. And I think you'd rather be uncomfortable and honest than comfortable and deluded. First truth: the Big Bang Theory doesn't explain where the universe came from. It describes what happened after a certain point. This distinction is absolutely crucial, and it's where most people get confused. So let me walk you through this carefully. When Edwin Hubble looked through his telescope in the 1920s, he noticed something shocking. He was measuring the light from distant galaxies, and he noticed that the light was shifted toward the red end of the spectrum. Now, this is important because of something called the Doppler effect. You know how an ambulance siren sounds higher pitched when it's coming towards you and lower pitched when it's moving away? That's the Doppler effect. Waves get compressed when the source moves toward you and stretched when it moves away. Same thing happens with light. Light from objects moving toward us shifts blue. Light from objects moving away shifts red. Every galaxy Hubble looked at, every single one, was redshifted. They were all moving away from us. All of them, in every direction. And here's the kicker. The farther away they were, the faster they were receding. This was observational gold. This was the kind of data that makes physicists wake up in the middle of the night, excited. It meant the universe was expanding. Not that things were flying apart from some central explosion point, but that space itself was stretching, carrying galaxies along with it like raisins in rising bread dough. Now, if things are getting farther apart right now, run the film backward and they must have been closer together in the past. Simple logic. Undeniable logic. Run it back far enough and you get to a state of incredible density and temperature. Everything squished together, compressed, unimaginably hot. This is what we call the Big Bang state. We calculate that about 13.8 billion years ago, everything we can observe in the entire universe was compressed into an unimaginably small, hot, dense point. Smaller than an atom. Maybe infinitely small. The math suggests a singularity, a point of infinite density. Now notice what I didn't say. Notice very carefully what I didn't say. I didn't say, the universe was created 13.8 billion years ago. I said, the observable universe was compressed into a hot, dense state. Big difference, enormous difference, universe-sized difference. The Big Bang theory describes cosmic expansion. It makes very specific, testable predictions. It says, if this is true, the universe should be cooling down as it expands, just like air cools when you let it out of a compressed tank. Check, it's cooling. The theory says there should be background radiation left over from the early hot state, a kind of afterglow from when the universe was so hot that atoms couldn't even form. Check, we found it in 1965. The cosmic microwave background radiation. It's everywhere. It's perfect. It's exactly what the theory predicted. The theory says the proportions of hydrogen and helium in the universe should match certain very specific calculations based on conditions in the early universe. Check. They match to absurd precision. Every prediction checks out. Every test passes. The theory is spectacularly, breathtakingly successful. It's one of the great triumphs of human reasoning. I'm not here to tear it down. I'm here to clarify what it actually says versus what people think it says. Here's where people get confused, where the slippage happens. Successful description doesn't equal ultimate explanation. The theory tells us the universe was in a hot, dense state and expanded. Full stop. That's what it tells us. It doesn't tell us why it was in that state. It doesn't tell us what before means, or if before is even a coherent concept. It doesn't tell us whether time itself had a beginning, or whether time is something more fundamental. It doesn't tell us whether our universe is all that exists, or whether it's one bubble in an infinite foam of other universes. We've done something psychologically slippery, something very human and very understandable, but ultimately misleading. We've taken a scientific model with precise, limited claims, and we've inflated it into a creation myth. We've turned the universe expanded from a hot, dense state into the universe exploded into existence from nothing. That second version? That's not science. That's storytelling. That's us satisfying our deep psychological need for beginnings and endings, for stories with a chapter 1. Science is humbler than that. Real science says, here's what we can measure. Here's what the math predicts. Here's the boundary where our equations break down, and we honestly don't know what's happening anymore. That last part, the breaking point, that's where the Big Bang actually sits. It's not the beginning of everything. It's the beginning of what we can currently describe with our current tools. Think of it like this. Imagine you're watching a movie and you walk into the theater late. The movie is already playing. You see characters in the middle of an argument. You can describe what you're seeing. You can say, the man is angry, the woman is crying, they're in a kitchen. All true, all accurate, but you don't know why they're arguing. You don't know what happened before you walked in. You don't know if this is the first time they've fought or the 100th. You're describing the middle of a story and calling it the beginning because it's where your observation began. That's us with the Big Bang. We're watching the universe expand, and we're running the footage backward until the film gets too damaged to read. And we're calling that first unreadable frame the beginning, because it's where our ability to see clearly stops. But the movie might have been playing long before we walked in. So if the Big Bang is just where our math breaks, what happens when we try to push past it? What's on the other side of that wall? And that brings me to the second truth, the one that really scrambles people's brains. Second truth. Time is not a river flowing from past to future. It's more like a dimension, similar to space. And once you really understand this, everything changes. Everything. In our everyday experience, time feels absolute. It flows. It marches forward relentlessly. You're born, you age, you die. Eggs break, but don't unbreak. Milk spills, but doesn't unspill. The arrow of time seems undeniable, carved into the bedrock of reality. This is how we experience the world. This is how we think. But Einstein showed us something radically different. He showed us that time is relative. It bends, it stretches, it slows down near massive objects or when you're moving at high speeds. There's no universal now that everyone agrees on. An event that's in your past might be in someone else's future, depending on your relative motion. If you're standing still and I'm flying by you in a spaceship at near the speed of light, we will literally disagree about what's happening right now on a distant star. Not because one of us is wrong, but because simultaneity itself is relative. Now is not an absolute concept. It's observer-dependent. This is weird. This is deeply, fundamentally weird. But it's not speculation. It's measured. It's tested. We have atomic clocks on airplanes and satellites that run at different speeds than clocks on the ground, exactly as Einstein predicted. Time is not the rigid framework we thought it was. It's flexible. It's part of the fabric of space-time, woven together with the 3 dimensions of space into a 4-dimensional whole. Now, when we combine this with quantum mechanics, things get truly bizarre. At the quantum level, particles don't have definite pasts until we measure them. There's this famous experiment, Wheeler's delayed choice experiment, that suggests the past can be influenced by measurements we make in the present. You can set up a situation where you decide how to measure a photon after it's already passed through a certain point, and your choice affects what the photon did back then. It's as if the past isn't fixed until you look at it. Causality itself becomes fuzzy, uncertain, negotiable. I know this sounds like science fiction. I know it sounds like I'm making this up. But this is the world quantum mechanics reveals to us. This is what the experiments actually show, again and again and again. Now apply this understanding to the Big Bang question. We ask, what happened before the Big Bang? But that question assumes something very specific about the nature of time. It assumes time is a container that existed independently, sitting there empty, waiting to be filled with events. It assumes time is the stage, and the universe is the play happening on that stage. But what if that's wrong? What if time itself is a property of the universe, not something the universe exists inside of? What if time is as much a part of the physical system as matter and energy? If time is a dimension woven into space-time, and space-time itself emerged from or expanded from the Big Bang state, then asking what came before is like asking, what's north of the North Pole? Think about that for a second. What's north of the North Pole? The question sounds reasonable. It has grammatical structure. It uses familiar words, but it contains a category error. Once you're at the North Pole, the concept of north loses meaning. Every direction is south. There is no more north to go. The question dissolves when you understand the geometry of the Earth properly. Similarly, if time is a feature of the universe that emerged with or from the Big Bang, there might be no before. Not because something prevented events from happening before, but because before requires time, and time might not exist independently of the physical universe. The question might contain a category error. It might be asking for something that's incoherent once you understand the actual structure of reality. But, and this is crucial, we don't know that time began. We don't know that for certain. We just know our current equations stop working at a certain point. They give us infinities. They give us nonsense. They break down. Maybe time really did begin with the Big Bang. Maybe it didn't. Maybe time is cyclical, looping back on itself. Maybe time is an emergent property of something deeper, some more fundamental substrate we haven't discovered yet. Maybe there are regions of a larger reality where time flows differently or doesn't exist at all. The honest answer, the only honest answer, is we don't know. But here's what's beautiful about this. Recognizing the limits of our concepts, recognizing that time might be a provincial, local phenomenon specific to our patch of reality, opens the door to possibilities way weirder and more wonderful than the universe started 13.8 billion years ago, and that's that. It means the mystery is deeper than we thought. It means we're still at the beginning of understanding, not the end. And that's exciting. That's the opposite of disappointing. That means there's still work to do, still questions to ask, still reality to grapple with. And if time itself is negotiable, if our basic framework is potentially flawed, what does that mean for the idea of a beginning at all? What does creation even mean if time doesn't flow the way we think it does? Let me show you where modern physics is actually heading with this. Let me show you the cutting edge, third truth. And this is the one that breaks people's brains. This is the one that makes people angry, uncomfortable, disoriented. Maybe there was no beginning. Maybe infinity is not a bug in our thinking. Maybe it's a feature of reality. Humans hate infinity. We are deeply, viscerally uncomfortable with it. It makes us want to run away. We want edges. We want boundaries. We want starts and stops. We want to point to a moment and say, there, that's when it began. It gives us psychological closure. It lets us sleep at night. Even physicists, people who should know better, people who work with infinity in their equations every single day, rush to insert a creation event into cosmology, because the alternative is too vertiginous, too dizzying, too much. But look at what modern physics is actually telling us when we're brave enough to listen. Look at where the math is pointing. Some versions of quantum cosmology suggest the universe could be in an eternal quantum state with no definite beginning. In these models, what we call the Big Bang is just one fluctuation, one particular expression in an infinite field of quantum possibilities. The universe doesn't start, it's always in a superposition of states, and the Big Bang is the crystallization of one particular outcome. But the underlying quantum field? That might be eternal. No beginning, no end, just an infinite space of possibilities, constantly collapsing and recollapsing into concrete realities. Then there are the cyclic models. These propose the universe goes through infinite cycles of expansion and contraction. Big Bang, expansion. The expansion slows, reverses, everything collapses back into a big crunch, which then triggers another Big Bang. Over and over, infinite cycles, no beginning to the chain, no end. Just eternal breathing in and out, expansion and contraction, like a cosmic lung that's been breathing forever and will breathe forever. There's eternal inflation theory. This suggests our Big Bang was just one bubble in an eternally inflating multiverse. Picture a pot of boiling water. Bubbles form, expand, pop. New bubbles form. The process never stops. Each bubble is a universe with its own Big Bang, its own laws of physics potentially, its own timeline. And the underlying field that's producing these bubbles? That's eternal. It's always been inflating, always will be inflating. Universes are being born constantly. The process never started and never ends. Our Big Bang was just one bubble forming in an infinite sea of bubble universes. And then, even stranger, Some interpretations of quantum mechanics suggest removing time altogether from the fundamental equations. In these frameworks, time is an illusion, an emergent property of our macroscopic experience. At the deepest level of reality, everything just is. Timelessly, eternally existing. The whole history of the universe, past, present, and future, exists all at once in a timeless quantum state. Time is something that emerges when you look at the system from the inside, from the perspective of a conscious observer embedded in the system. But fundamentally, no time, no sequence, no before or after, just existence. Now, none of these are proven. I want to be crystal clear about that. These are speculative. These are hypothetical. These are physicists taking the math seriously and asking, what if we follow these equations all the way? What do they imply? They're not fringe nonsense. These are serious proposals published in serious journals by serious physicists. But they're not settled. We don't know which, if any, is correct. But here's the pattern I want you to notice. Here's what's happened again and again throughout the history of science. Every time we think we've found a boundary, a limit, an edge to reality, we later discover it was just a limit of our perspective. The Earth feels flat when you're standing on it, but it's not flat. It's round. The horizon isn't the edge of the world. It's just the edge of what you can see from where you're standing. The solar system isn't the universe. It's one solar system among billions in our galaxy. The Milky Way isn't the only galaxy. It's one galaxy among hundreds of billions in the observable universe. The universe isn't static. It's expanding, dynamic, evolving. Every time. Every single time. We thought we had it figured out, and reality was bigger, stranger, more extravagant than we imagined. So why would the beginning be any different? Why would this be the one time where we actually found the real edge, the real limit? Isn't it more likely that the Big Bang is another horizon, not an edge? Another limit of our current perspective, not the boundary of reality itself? Maybe the universe doesn't owe us an origin story. Maybe existence is more fundamental than causation. Maybe the question, why is there something rather than nothing, is as confused as asking, why is there up rather than down? That second question presumes a symmetry that doesn't exist. Up and down aren't opposites in some cosmic scale. They're directions relative to a gravitational field. Without gravity, without mass, the concepts lose meaning. Similarly, maybe something versus nothing is a false dichotomy. Maybe nothing isn't even a coherent concept. Maybe existence is the ground state. Maybe the default. Maybe asking why there's something rather than nothing is like asking why there's existence rather than non-existence, when non-existence might not even be a possible state of affairs. This isn't defeat. This isn't me throwing up my hands and saying we can never know anything. This is liberation. This is permission to stop torturing yourself trying to imagine what nothingness looks like. Permission to stop trying to conceive of before time. You can accept that some questions might dissolve when we understand them more deeply, that some questions reveal themselves to be based on flawed premises. The terror of infinity becomes the wonder of infinity. The discomfort of not knowing becomes the excitement of genuine mystery. You don't have to have it all figured out. You don't have to pretend certainty. You can sit in the uncertainty and find it beautiful. Okay, I've just thrown a lot at you. Metaphors and paradoxes and speculative physics and ants on balloons and movies and North Poles. Your brain is probably doing somersaults right now. You might feel a little dizzy, a little unmoored. That's normal. That's good, actually. That means you're actually thinking about this, not just passively absorbing it. So let me bring this down to earth. Let me give you 3 practices, 3 ways to actually use this understanding in your life, in your thinking right now. Because philosophy that doesn't change how you live isn't philosophy. It's just word games. First practice, and this is the hardest one for most people. Start noticing when you're pretending to understand something you don't. and practice saying out loud, "I don't know," and that's okay. This sounds simple, it sounds trivial, but it's radical. It's revolutionary. We live in a culture that rewards certainty, confidence, having answers, being decisive. Saying "I don't know" feels like failure. Feels like you're not smart enough, like you haven't done your homework, like you're falling behind all the people who seem to have it figured out. But here's the secret, and I've known this for 70 years of doing physics. The smartest people I've ever known, the real geniuses, the ones who actually moved the field forward, are comfortable with uncertainty. They can hold a question without collapsing into a premature answer. They can say, "This is fascinating, and I don't understand it yet, and I'm going to keep thinking about it." They don't need the psychological comfort of a tidy answer. They're comfortable in the mess. The people who pretend to know everything, they're either lying or deluded, and usually both. The universe is too big, too strange, too complex for any human brain to fully comprehend. Anyone who tells you they have it all figured out is selling you something. So try this. Try it this week. When someone asks you a big question about God, about meaning, about consciousness, about what happens after death, about how the universe started, instead of reaching for a comfortable cliché or a half-believed answer you picked up somewhere, try saying, "I don't know. I've thought about it, and I genuinely don't know. Isn't that interesting?" Watch what happens. Some people will be uncomfortable. They'll push back. They'll say, "But you must have some theory." They need you to play along with the game of certainty. That's fine. Let them be uncomfortable. But other people, the interesting ones, will lean in. They'll say, "Me neither." And suddenly you're having a real conversation instead of a tennis match of certainties. You're actually exploring together instead of defending positions. Not knowing isn't ignorance. Not knowing is the starting point of wisdom. It's the doorway to actual learning. As long as you think you already know, you can't learn anything new. Your cup is full. But empty your cup, admit you don't know, and suddenly there's room for reality to surprise you. Second practice. When you hear a scientific claim, any scientific claim, ask yourself, is this describing what happens or explaining why it happens? This distinction is everything. This is the difference between science and scientism, between understanding and ideology. The Big Bang Theory describes cosmic expansion. It doesn't explain why expansion occurred in the first place. Evolution describes how species change over time through mutation and selection. It doesn't explain why life exists at all or why the universe is capable of producing self-replicating systems. Quantum mechanics describes the behavior of particles with extraordinary precision. It doesn't explain why reality is quantum, why the universe operates according to these particular rules rather than some other rules. This distinction matters enormously. Most arguments between science and religion, between materialism and spirituality, between different worldviews happen because people confuse these levels. Someone says, "Science has shown that the universe began with the Big Bang." But what they mean is, science has described a pattern of cosmic expansion. The listener hears, "Science has explained the ultimate origin of everything, and there's no room for anything else." And then the fight starts. But the fight is based on a confusion. Practice catching this in real time. Listen to a documentary about cosmology. Read an article about neuroscience and consciousness. Notice when "we have observed X" slides imperceptibly into "therefore Y is the ultimate truth about reality." Notice when a map is being sold as the territory. Notice when description is being inflated into metaphysics. This doesn't make science less valuable. It makes it more valuable. Science is astonishingly good at description and prediction. That's its superpower. That's what it's optimized for. We can describe how stars form, how light bends around massive objects, how chemicals react, how genes are expressed. We can predict eclipses centuries in advance, land robots on Mars, cure diseases, build computers. This is extraordinary. This is humanity at its best, but demanding that science also provide ultimate meaning, ultimate purpose. The answer to, why is there something rather than nothing, is like demanding your thermometer tell you who to marry. It's the wrong tool for the job. The thermometer is great at measuring temperature. Don't get mad at it for not solving your relationship problems. When you can distinguish these levels clearly, you stop expecting physics to answer philosophical questions, and you stop dismissing philosophy as just speculation that's inferior to science. You can hold both. You can be rigorously scientific about what science can address, and rigorously philosophical about what it can't. You can be scientific and humble about the limits of science at the same time. Third practice, and this one might sound weird, but trust me on this. Spend 5 minutes this week sitting with the feeling of infinity. Just the raw feeling. Not thinking about it. Not analyzing it. Just feeling it. Here's how you do it. Find a quiet place. Close your eyes. Take a few breaths. Now imagine space extending outward from where you're sitting. Outward past the walls of your room. Past your house. Past your city. Keep going. Past the Earth. Past the solar system. Past the galaxy. Past the cluster of galaxies. Farther, farther. Imagine it never stopping, never ending. No wall, no edge, just more space. Forever. Notice what happens in your body when you do this. Does your stomach drop a little? Does your breath catch? Do you feel a little dizzy, a little vertiginous, maybe a little awe, maybe a little terror, maybe both at the same time? Good. That's the feeling I want you to notice. Sit with it. Don't try to resolve it. Don't reach for a comforting thought like, but God contains it all, or, but it probably does end somewhere we just can't see. Just sit with the raw experience of endlessness. Let yourself feel small. Let yourself feel the scale. Then do the same thing with time. Imagine the past extending backward. Before you were born. Before your parents were born. Before humanity existed. Before the Earth formed. Before the solar system. Before the galaxy. Keep going backward. Before the Big Bang. Keep going. Imagine it never starting. No first moment, just infinite past extending backward forever. Notice the discomfort, the way your mind wants to flinch away. Stay with it. Breathe. Feel it. This isn't about reaching a conclusion. This isn't an intellectual exercise. It's about training your nervous system to tolerate uncertainty and vastness without shutting down. Most of us never do this. We think about infinity for 3 seconds, feel uncomfortable, and immediately grab our phone to distract ourselves with something manageable, something finite, something we can control. But if you can sit with it, if you can really sit with the feeling of infinity for even just 5 minutes, something shifts. The terror becomes curiosity. The vertigo becomes awe. You start to understand viscerally, not just intellectually, that the universe is under no obligation to make sense to you. That reality is bigger than your ability to conceptualize it. And paradoxically, instead of making you feel disconnected or small in a bad way, it makes you feel more connected, more part of it, because you're not fighting it anymore. You're not demanding it fit into your categories. You're letting it be what it is. 5 minutes, this week. Try it. See what happens. I think you'll be surprised. All right, let's bring this home. Let's land this plane. We started with a question that's been haunting humanity since we first looked up at the stars and wondered, where did all this come from? How did it begin? Why is there something rather than nothing? These are the deepest questions we can ask, the most profound, the most important. And I told you something uncomfortable. I told you we don't know. The Big Bang isn't the answer you thought it was. It's not a creation event where the universe exploded into existence from nothing. It's a description of cosmic expansion. It's the horizon of our current understanding, not the edge of reality itself. It's where our equations break down, and we have to be honest and say, beyond this point, we're guessing. But here's what you've gained. Here's what's different now from when we started. You've learned to think like a physicist, Not like a physicist in the sense of memorizing equations. Anybody can memorize equations. But thinking like a physicist in the deeper sense. You've learned to distinguish what we know from what we've mythologized, to separate description from explanation, to get comfortable with uncertainty without collapsing into either dogmatic certainty on one side or nihilistic despair on the other. You've seen that time might not be what you think it is, that it's not this rigid container everything happens inside of, but a flexible dimension woven into the fabric of space-time itself. And if time itself is negotiable, if time might be emergent or cyclical or even illusory at the deepest level, then the whole question of the beginning transforms. It might not even be the right question to ask. You've seen that infinity might be more real than beginnings, that the universe might be eternal in ways we're only starting to glimpse, that what we call the Big Bang might just be one event in an infinite process, one bubble in an eternal foam, one cycle in an infinite series of expansions and contractions. And most importantly, you've learned that the smartest thing you can do is admit when you don't know. That intellectual humility isn't weakness, it's strength, it's honesty. It's the only rational response to a universe this vast, this strange, this beautiful. This isn't just about cosmology. This is about how you hold reality. Do you need tidy answers to sleep at night? Or can you dance with mystery? Can you be intellectually honest and emotionally okay at the same time? Can you sit with the big questions without immediately reaching for comfortable lies? Here's what I want you to remember. Here's what I want you to come back to when the vertigo hits, when the uncertainty feels overwhelming, when you're lying awake at 3 a.m. trying to imagine what before time could possibly mean. Here's your mantra. You are not broken for not understanding infinity. You're human, and your confusion is not a flaw. It's not a sign that you're not smart enough or haven't thought hard enough. It's your brain brushing up against something bigger than itself. That's not failure. That's contact with the real. That's your mind touching the edge of what minds can do. And that's beautiful. That's precious. That's the most honest thing you can experience. The universe didn't start with the Big Bang. Or maybe it did. Or maybe the question itself is confused. We don't know. But your willingness to think clearly, to be honest about what we know and what we don't, to hold uncertainty with grace, that can start right now. That's available to you immediately. You don't need a PhD in physics. You don't need to understand the equations. You just need to be willing to say, I don't know, and I'm okay with that. If this resonated with you, if you felt something shift even a little, if some knot of confusion loosened just slightly, do me a favor, hit the like button. Not for the algorithm, though that helps too, but because it tells me I'm not alone in thinking we need more honest conversations about what we don't know. It tells me there are other people out there who are tired of fake certainty and hungry for real thinking. Drop a comment and tell me, what's the question you're most comfortable not having an answer to? What's the mystery you've made peace with? I read every single comment, and I learn from you. Some of the best insights I've had have come from conversations in the comments. You're not just an audience, you're part of this exploration. And if you want more of this, more thinking that doesn't insult your intelligence or pretend certainty where there isn't any, subscribe. Stick around. Let's keep asking the hard questions together. Let's keep pushing against the boundaries of what we can know. Let's keep finding the beauty in not knowing. Because the universe didn't start with the Big Bang. The universe is weirder, more mysterious, more wonderful than that. And the adventure of trying to understand it, of bumping up against the limits of what human minds can comprehend, that's what makes life worth living. Thanks for watching. Now go sit with infinity. Let it wash over you. Feel how small you are and how connected you are at the same time. I'll be here when you get back.